Hello and welcome to Maths with Martin. I'm Martin, an A-level maths teacher of over 7 years, and in this video we're going to look at a topic that is pretty much guaranteed to come up on Edexcel paper 2, Binomial Expansion. There was none last week on paper 1, and it is a topic that they certainly will want to test at some point. Now, generally these questions, most of them, it's just a case of you need to learn the technique to be able to expand these brackets, and the instructions will be fairly simple in terms of just expand this for the majority of the questions that you see. I've also though tried to throw in some of the questions that I've created here, some slightly harder parts of these questions, just to give a little bit of variation and just kind of push you to some of the harder things that you could possibly see within this topic. We'll get started with our first question, and we need to find the x squared term in the expansion of these two brackets. Now, to do this, the first term is, I don't need to do any expanding there, but the second bracket, this is to the power of 7, okay, a positive integer. So I want to use the version of the binomial expansion that I'll get up on screen now. Okay, this can just be found in your formula book. Now, typically I find that my students don't really use this. They kind of just learn the sort of pattern with the binomial expansion. But, if in doubt, you can use this. Now, in this question, we don't need to expand that second bracket. We don't need to, multiply all the brackets together and find the constant, the x term, the x squared term, all the way up to x to the power 7. That's just going to waste time that we don't have in the exam. So what I need to think about is I'm taking the first bracket and I'm going to multiply it by all these terms in the second bracket. So there will be a constant term, an x term, an x squared term, an x cubed term, all the way up to x to the power 7. But what I want to do is just find the relevant terms that I actually need. So I'm looking to make some x squared terms here. Now in the first bracket, I've got an x as the first term, okay? X to the power of 1. So in the second bracket, I'm interested in the x term in that bracket, because when I do x times x, I'm going to get an x squared. So that's the first thing we're going to do. We're going to find the x term in that second bracket. Okay, so the first thing we're going to do is find that x term. So to do that, I'm just going to use this part of the binomial expansion here to get that x term. So I'm going to do 7 choose 1. And then you've got this a to the power of n minus 1. So this would be 2 to the power of 6. Okay, n is 7 here because the power of this bracket is 7. And then times that by x over 4 to the power of 1. And then we can just calculate this. 7 choose 1 is 7. 2 to the power of 6 is 64. And then I just have the x over 4. If I multiply that all together, I get 112x. And as we mentioned earlier, if we take the x from the first bracket and we times it by the x in that second bracket when I've expanded that all out, then that's going to give me an x squared term. Now, the second term in the first bracket, we've got that 4 over x squared. And it might be more useful to think of that as 4 times x to the minus 2. So then I need to think, okay, well, I've got x to the minus 2. What would I need to multiply that by to make an x squared term? So if I've got x to the minus 2, if I times it by x to the 4, that's going to give me a x to the power of 2 term. So let's find x to the power of 4. So you can just see here in the formula book, you've got this general way of finding any term in your expansion. Again, I find most students don't really use this. They kind of just acknowledge the pattern here, but you have got it there if you need it. So we're looking for the power of 4 term. So I'm going to do 7 choose 4. Okay, n is 7, this r is just this 4, the term I'm looking for. And we then times that by 2 to the power of 3. Okay, you're doing a to the power of n minus r, so 7 minus 4 for 3. And then you times it by this x over 4 to the power of 4. Yeah, again, you can check your powers add up to make 7 here, which they do. So 7 choose 4, you can use your calculator for this, you get 35. 2 to the power of 3 is 8. And be really careful with this bit. This is a common mistake I see people make all the time. When you do x over 4 to the power of 4, make sure you do your denominator to the power of 4 when you're working out that fraction. So you're going to do the top and the bottom of that fraction to the power of 4. So x to the power of 4 and 256 on the bottom there. And then just work that all out and you get 35 over 32 x to the power of 4. And that's our x to the power of 4 term now. So now what we can do is we can work out what our x squared term is going to be when we expand the whole thing. As I mentioned at the start, if you fully was to expand the whole thing, you'd have your constant, your x squared term, all the way up to x power 7. But we don't need to do all that. Okay, so we're just going to do x times, so we're going to take the x from the first bracket, and then from the second bracket, I want to look at the x term there. So I take that x, times it by 112x, and I get 112x squared. And then when I've got the minus 4x to the power of minus 2, I'm then going to times that by the 35 over 32x to the power of 4 that I found in the second bracket. Just really make sure, by the way, when you do this, that you make sure you don't forget about that minus. And we get minus 35 over 8x squared when we do that. So the coefficient, okay, so if we were to expand the whole thing out, we get all these terms, but the only ones I'm really interested in are the x squared terms. So I get 112x squared, I'd get minus 35 over 8x squared. So then I would just add the 112 and the minus 35 over 8 together. And we're just going to leave this as a fraction here. And that's going to be 861 over 8. Remember, we are only asked for the coefficient. So don't put that x squared on there. Just put that 861 over 8. Okay, in the second question we've got here, we're going to find the first three terms in ascending powers of x of the binomial expansion of 1 over the square root of 9 minus 2x, giving each term in the simplest form. Now, with this one, we can't use the version of the binomial expansion that we used for the first question because our power of the bracket is no longer going to be a positive integer. So let's just bring up the version that we're going to use from the formula book. So before I use this, I just want to rewrite this 1 over the square root of 9 minus 2x. So first off, because you're square rooting, we're just doing to the power of a half here. And then, rather than write it as 1 over, I can just write it as 9 minus 2x to the power of negative a half. And because we've got negative a half as our power, I'm going to need to use this version of the binomial expansion. Now, in this version of the binomial expansion, we need to make sure we have a 1 in the bracket. So the first thing I need to do before I get to using that is just rewrite this 9 minus 2x to the power of minus a half. So I would take out the 9 here. So if I take the 9 out of this bracket, I've got 1 minus 2 over 9x left in there. But we have to make sure that all of that is still being taken to the power of negative half. Okay, I've just rewritten this 9 minus 2x as 9 bracket 1 minus 2 over 9x, but all of that is still being taken to the power of a half. So if I do 9 to the power of negative a half, that's going to be 1 over 3, and then I'm timesing that by 1 minus 2 over 9x to the power of negative a half. So what I can do now is use the binomial expansion on this bit here, but I then just need to times everything by a third at the end. Please don't forget about really important step about taking the 9 out, but then making sure you're doing that to the power of negative a half. I do see quite a lot of common mistake is people just take out the 9, but then don't consider that they're going to have to do that to the power of n when they do that. So we're going to work out what 1 minus 2 over 9 x to the power of negative a half is, and then we'll times that by a third at the end. So I'm just going to put on the outside here this third. So using this expansion, the first term is just always going to be a 1. And then I'm going to work out that nx term. So n is my power, so that's going to be negative a half. And then x is just this minus 2 over 9x. Okay, so basically we just replace the x with minus 2 over 9x. So let's pop that in. And then we do, for my next term, I do n, which is, yeah, again, that's minus a half, times n minus 1, that's minus a half minus 1, divide that by 1 times 2, which is 2, don't know why I need to say that, and then we times that by x squared, so we got 2 over 9 x all squared. Yeah, again, as I mentioned earlier with the first question, make sure that we are squaring both the minus 2 here and the 9 as well. And we don't need to go any further than that because we're only asked to find the first 3 terms. So simplifying this in the bracket here, just timesing these out, if I do minus a half times minus 2 over 9, I get plus 1 over 9x, and then just simplifying all of this. Just be really careful when you're working this out. Even if you're using your calculator, just be really careful with your how you input it in. There can be a lot of mistakes made from doing this, so just take that extra care when you're doing that. And then we're just going to multiply that all by a third here. And we have all 3 terms that we need to find there. Really recommend that you do lots of practice with these, because those types of questions, there's not some weird modelling or problem solving that you're having to do. It's a very simple instruction. Find the first 3 terms. So if you've done the practice, that shouldn't be too bad. Okay, there's no kind of curveball they can throw at you there. Now, we'll get on to parts B and C. C is going to be a bit more involved. B is quite a common thing about where this is going to be valid. So if we look back to what's in the formula book here, we get told that the modulus of x has to be less than 1. Okay, but we don't have x, we have minus 2 over 9x. So the modulus of minus 2x over 9 has to be less than 1. So what I'm just going to do is I just want to look at what values of x it's valid for, and I'm just going to simply multiply by 9 and divide by 2. And I'm just going to ignore the negative because we're taking the modulus of this anyway. So multiply by 9, divide by 2, and then those are the values of x where it's going to be valid. Okay, so nice and simple. It's only 1 mark, so we're not going to have to do much for that. Now in part C, we're asked to use our expansion from part A and the substitution x equals 1 to get an approximation for the square root of 28. Okay, so this is going to require a little bit more thought. So the first thing I'm going to do is just sub x equals 1 into 1 over the square root of 9 minus 2x. So when I do that, that just gives me 1 over the square root of 7. So if I'm to sub in x equals 1 into that expansion, then I'm just going to get the result of 1 over the square root of 7. Okay, that's not what I want. So I now need to think, okay, well, how can I make this, what do I need to do to turn this into the square root of 28? Now what I'm going to do is I'm going to say, right, I've got 1 root 7 here, 1 over root 7 here, and I need to times it by something to get to root 28. So I'm just going to rearrange this equation I've got here and say, well, k has to be root 28 times root 7. And, well, root 28 is root 4 times root 7, and I've got that root 7. So k is going to be root 4, which is just 2, and then root 7 times root 7 is just going to be 7. So k is going to be 14. So to find an approximation for the square root of 28, what I'm going to do is I'm going to sub in x equals 1 into my expansion. So 1 over 3 plus 1 over 27x plus 1 over 162 x power of 2. So I'm going to plug that in. Okay, I'm just plugging in x equals 1. As we discussed earlier, this here would just be an approximation for 1 over root 7. So if I times 1 over root 7 by 14, then that would give me an approximation for the square root of 28. So when I work that out, make a little bit more room. When I work that out, I get the square root of 28 is going to be approximately 427 over 81. We're just going to leave it as a simplified fraction there. Okay. And for our final question, I thought I'd show you one where you've got a fraction that you need to simplify, and you'll need the binomial expansion to be able to do that. So we've got here 1 minus 3x in the bracket squared, and we're dividing that by the square root of 1 plus 2x. So we're going to need the binomial expansion to get what the first 3 terms of this would look like. So rather than think of it though as a division problem, what I want to do is to reimagine this as 1 minus 3x to the power of 2, and I'm going to times that by 1 plus 2x to the power of negative a half. Very similar to what we did in the last problem. If you square root something, you're doing it to the power of a half. So if it's 1 over, that will be to the power of negative a half. So we're going to expand these brackets out, but we're only going to go as far as x squared, okay? Now, the first bracket, you don't need to be using the binomial expansion there to expand that out. You can just do your double brackets to expand that out, and that will just simply be 1 minus 6x plus 9x squared, okay? And those, that's exact. No binomial expansion required there. Then we'll look at the 1 plus 2x power of negative a half. This is a little bit simpler than the last problem that we looked at because you've already got the 1 there, so there's no need to take anything out. This is a little bit more straightforward in that regard. So when I use the expansion, the first term is a 1. The next term is n times x. N is minus a half. X is just 2x here, so we're going to do minus a half times 2x here. And then the final term is just going to be this one here. So we've got minus a half, that's our n. n minus 1 would be minus 3 over 2. And then you've got 2 times 1, and then you've got this 2x in a bracket squared. Please don't forget to square the 2. I know I keep mentioning it, but please don't forget. So just simplifying this, we've got 1 plus minus a half times 2x, that's just minus x. And then you've got minus a half times minus 3 over 2 divided by 2 times by that 2x in the bracket squared. When you calculate that all out, you get 3 over 2x squared. So then what we're going to do is we're just going to simply expand this out. So we've got our first bracket. That's what it will look like when we expand this out. The second bracket, now this is an infinite series. This would just go on, but we only need to go as far as x squared. So I don't need to multiply out everything. I just need to multiply out the terms that are going to give me an x squared. Now, what you might like to do here, I know a lot of people like doing multiplication with some sort of grid method. So you might just want to do a little grid method here just to see what are the relevant terms that you are looking for here. Okay, so we've just got here that when we do 1 times 1, we're going to get 1. That is a term that we're interested in. Okay, 1 times minus 6x, that's going to be minus 6x. And then we've got this 9x squared. Okay, all of those are terms that we are interested in because we want the first 3 terms. So that will be the constant term, the x and the x squared. I mean, you can always check as well with the answer that we only need to go as far as x squared. So we're interested in all 3 of those terms there. Then I'm going to do minus x times the 1. Yep, x, interested in that. Minus x times minus 6x, that's going to be 6x squared. Yet again, we want that. But minus x times 9x squared, don't care. Okay, so we're not going to bother working that one out. And then the 3 over 2x squared term, we're only interested in timesing that by the 1. When we times it by the x, we times it by the x squared. We're going to get x cubed terms. We're going to get x power 4 terms. Not interested. So these are the only ones that I want here. So expanding this all out, what I'm going to get is I'm going to get 1 minus 6x minus x, and I'm going to add the 9x squared, the 6x squared, and the 3 over 2x squared. And simplifying that, we've got 1. Collect together your x's, you've got minus 7x here. And then finally collect together all your x squared terms, the 9, the 6, and the 3 over 2. And you'll get 33 over 2x squared. And that's all we need to do for that part A. For part B, we're just going to state where this is valid. So when you get questions like this, sometimes you do get ones where you have to use the binomial expansion twice here. Okay, you didn't really need to use it for the first, for the top of this fraction. But if that's the case, you're just going to make sure that you always go with, what works for all, for both expansions. Don't just kind of look at what works for one. It needs to work for both of them. So in terms of the top of that fraction, this will work for any value of x. So we don't need to worry about where that is valid. But the denominator, we're yet again going to use this part where the modulus of x is less than 1. But here, I don't have x. I have modulus of 2x. So I have 2x here. So I need to look at where the modulus of 2x is less than 1. And I can just divide both sides by 2 here. So it's just valid for where the modulus of x is less than a half. Okay? Let me know if you've got any questions with this. And good luck in your exams.